So in the last video, we went through the basics of data warehousing, and in this one, we will just go through the OLAP technologies. Uh, as I have explained in the last time, OLAP differs from traditional OLTP. So OLTP stands for Online Transactional Processing, and OLAP stands for Online Analytical Processing. This is mostly used in traditional database systems. This is used in mostly data warehouses. And since this entire series is based on data warehousing, this so this is why we'll be focusing on. So let's get into. So I'll divide this into two main sections. Let's first look into the OLAP servers, or also called as types of OLAP technologies or types of OLAP systems. So OLAP systems. Let's discuss types of OLAP systems. Now, what is an OLAP? So, online analytical processing refers to a set of software tools used for data analysis in order to make business decisions. Again, just a set of software tools made for making business decisions. This is basically a BI tool, so business intelligence tool. OLAP provides a platform for gaining insights from databases retrieved from multiple database systems at the same time. So this multiple database thing is the concept of data warehousing. So since this is part of data warehousing, you get the advantages of being a data warehousing thing. Data warehousing aggregates information. It doesn't aggregate, but it makes available information from all types of database systems. It is now OLAP is based on a multidimensional data model, which enables users to extract and view data from various perspectives. A multidimensional database is used to store OLAP data, and many business intelligence applications rely on OLAP technology. So, again, BI. So, data warehousing, OLAP, it is for BI. And a multi-database, multidimensional, is used for multidimensional database is used to store lab data. So, and now there are types of systems, and let's look at them. So, let's get into the main types of database systems. First, look at relational OLAP. Relational OLAP, also called as remote cassette rollup. So this is mainly star-based system. Now, if you guys remember, if from your knowledge of databases, there is a architecture, or there is a type of database system called as fact and dimensions. So basically, you have a fact here, and you have dimensions in star, right? So, for example, if this just stores about customer, this stores about these dimensions. They store about the information like uh, the customer address, name, details. So, and this relational OLAP is based on star-based, star schema-based, and it operates on the principle that data can be viewed multidimensionally without being stored in multidimensional format. Stores in relational databases and uses SQL queries to perform operations like slicing and dicing, and adding where operations. Now, it It's important to know that it is compatible with OLTP systems because this is traditional, this is relational database, and the data size limits under lab technology it is determined by the underlying RDBMS itself, so the relational database system management system itself. So ROLAP it does not itself have any limit on the amount of data that can be stored. And it does have some limitations. Just because you're using SQL, the SQL functionality is constrained. It's difficult to keep aggregate tables up to date. And so if you go to the multi-dimensional OLAP, that would be the second one to discuss here. So yeah, let's move this down below. It's the next concept. So multi-dimensional OLAP, also called as MOLAP. So this is a cube based. What exactly is a cube? So as you saw here, as you're seeing here, this is a cube. This is a data cube. So now MOLAP stores data in a specialized multi-dimensional array format on disk, as we just saw. Now humans can only see three dimensions, but there could be many dimensions, as we know. And now these are not dimensions in the physical sense. Obviously, these are just dimensions. I mean, dimensions here just means the columns. So like if you just have, so that is just the number of dimensions, and each cell in an array represents a combination of dimensional values and holds corresponding measure as a fact data. Now, all operations are performed using fast random access capabilities of arrays. So this is used for like fast random access, and the data is stored in linear order based on a fixed sequence of dimension traversal, enabling quick retrieval and analysis. And unlike ROLAP, which stores only records with non-zero facts, MOLAP defines all possible combinations of dimension values, making its arrays sparse. Most cells are empty. So I just read that off of a website, but let me unpack it. So now, basically, MOLAP combines different dimensions data and then enables fast random access. Now it takes time to build this thing, so it's not so even though it offers a quick retrieval and it's ideal for like slicing and dicing, which we will discuss later. Slicing and dicing and micing. So and it's about complex calculations. So um, this it uses indexing and hashing for efficient data retrieval. So takes time to build it actually. So time to build it in first place. Once you build it, it is however very fast to access it. And benefits are that it's suitable for slicing and dicing, or it outperforms rollup when the data is dense. It's capable of performing complex calculations. So enables complex calculations. Calculations. The limitations are that it's difficult to change dimensions without re-aggregating. And since all calculations are performed when the cube is built, large amount of data cannot be stored in the cube itself. So then we have a hybrid OLAP, also known as HOLAP, which is just a combination of both a rollup plus HOLAP, MOLAP. Now it benefits from HOLAP. It benefits from rollups scalability, and it benefits from fast performance from MOLAP. So it, now the cubes are smaller than in the MATLAB. So cubes are smaller than in MATLAB. The reason is because the data is the detailed data is stored in the relation database. So you're using both relational and MATLAB. So now the limitations are that because it supports both MATLAB and ROLAP, it's quite complex. Would be the complex to build, and there is a greater likelihood of overlap in their functionalities. Now, so this is the type, and let's this even further down. So now we have some other types of OLAPs, uh, like web OLAP, and we have desktop OLAP, and we have mobile OLAP, and spatial OLAP. So you might as well invent your own type of OLAP. Now, the web OLAP is just a web browser-based OLAP solution that operates on a three-tier architecture: client, middleware, and database server. Unlike traditional client-server OLAP, no software installation is needed. Only a browser and internet access is needed. And this is pretty much like if you're using like Tableau, dashboards, and all that's just web OLAP. Desktop OLAP is just doing all the OLAP on your desktop. This is not recommended. This is like for very small data sets. It's pretty cheap. You just download the data and you use your desktop software and you just do the data analytics. Mobile app is for people like somebody working on an oil rig or something like that, where you need to move, you need to be on the move. You download the data on your phone and then you do the OLAP, just a wireless functionality for mobile devices. User can work and access the data to the mobile devices. Now, spatial OLAP combines geographic information systems with OLAP, allowing users to explore spatial data uh, in a single interface. It supports quick map-based analysis of spatial databases. There's also a real-time OLAP, which is also called as a ROLAP, not to be confused with relational OLAP. It combines OLTP and OLAP, enabling real-time analysis as updates occur. So it's kind of like a TP plus OLAP real time. And this is a cloud OLAP. It can be mostly accessed through web, and it offers high scalability, cost efficiency, and high availability and disaster recovery. And there's also big data lab, which handles large scale data platforms like Hadoop. And then there is in memory OLAP, which stores data in memory in the RAM and enabling rapid processing and real time analysis, support large data sets, complex analysis, and advanced analytics such as data mining and predictive modeling. So, as you might guess it, so those are this for big data. It's like Hadoop this stores in RAM, fast access. Yeah, those are the concepts. So that completes the types of OLAP systems. Relational OLAP, star based, uses traditional database management system structure. Now, multi-dimensional OLAP uses cube-based modeling, and it's idea for slicing and dicing. And third one combines both ROLAP and MOLAP advantages. It's hybrid OLAP, and there are several types of other OLAP systems. Now we'll just get to the OLAP operations. This is where it gets. So this is literally. So we had only like two parts. So this is the second part, and this is about it basically. So OLAP operations. So now OLAP is a software technology that enables users to analyze data from multiple database systems simultaneously. As we saw, it is based on multidimensional data model where data is represented in the form of cubes, and is also known as hypercubes. So these cubes, also called as hypercubes, each cube consists of dimensions and measures. Dimensions like location, time, and product. Measures like sales and profit. Now, OLAP is widely used in data warehousing and business intelligence, as we know. And let's get down to key operations. So, first one is drill down. Drill down. So, what exactly is a drill down? Let's say there is a cube, data cube like this, and when you say drill down, it becomes like basically we expand it. So, expand, let's say, uh, on this along this dimension. That's what drill down is, as we can see here. So, yeah, so this is the drill down. So, drill down is operation provides more detailed view of data, and it moves from a summary level to a lower level in concept hierarchy. Let's say like from year to quarter to month. So, if it just had like a year, now we have like a quarter to month. Let's say so. More detailed view. Now there is roll up. What is roll up? Well, it's just the opposite. So you have the detailed view. Say you have a lot of details. Just roll it up. So it's the opposite of just drill down. It aggregates and summarizes and to provide a higher level overview. Just combines. It is basically like climbing up in the concept hierarchy and reducing the number of dimensions. So, for example, if you had like quarter and month, you just roll it up to year. Third operation would be slice operation. What is slicing? So, as you can see, slicing operation is just selecting like a single dimension and from a cube, creating a new subcube with reduced dimensionality. Okay, so let me write it down. This is so just like selects single dimension from the cube, creating a new subcube with reduced dimensionality. So it has focus on the specific data slice for analysis. So let's say in the data we had Q1, Q2, Q3, we can just slice the Q1 only and analyze it across all products and regions for only the Q1. So that would be slicing. As you can see, this they're doing is slicing. They're just slicing one quarter from all the quarters. And fourth one would be dicing. What is dicing? So dicing is it selects data from cube by applying one, two more dimensions to form a subcube by applying filters. So yeah, so dicing is basically uh, you apply filters to create a specific subcube. Now, slicing is the same as dicing, except it's more a special form of dicing. Slicing. Okay, so that's actually wrong. So slicing and dicing are actually different. They are distinct but complementary operations. Uh, they are in slicing, you select just a single value for one dimension. Select a new subcube with one fewer dimensions than the original cube. So just one fewer dimensions. So here we're selecting one fewer dimensions. So now dicing is the process of creating a subcube by selecting two or more specific values across multiple dimensions simultaneously. So in essence, slicing provides a focused single dimension view, but dicing provides a more specific multi-dimensional view or cross section. One approach is dicing. Dicing is to first slice and then cut the resulting slices further. So dicing is more slicing. So this is uh, like slice and cut further. That will be dicing. Now let's come to another operation, that is pivot. And as you might have seen, if you have used like a 3D software like Blender or AutoCAD, you might know what pivot is like. So yeah, that pivot is different. So um, here pivot means just or it's kind of similar basically. So we take uh, like we take so so pivot just reorients the cube to provide a different view of the data. It helps you visualize data from different perspectives. So for example, you may want to swap the time and location axis to compare the sales per quarter across different regions. So let's say like we had let's say we had here locations and here let's say we had the population. If we take a different example, so location here, population. So you may want to kind of pivot it to make it look like population is here and the location is here. Okay, so again, don't think this as a like a real cube. This is again like a data. So if these are swapped, the other things may get jumbled. So don't imagine like a real cube. Let me just avoid confusion by removing this. So yeah, this is now called as pivot. So just rearrange cube to provide a different view of the data just by rotating rows and columns. Rotating rows and columns. Yep, so that completes it. So we saw about OLAP operations, drilling down, basically getting more data, rolling up, basically compressing it. Slicing is when you cut one dimension. Dicing is when you cut more to get and apply more filters to form even more subcube. Pivoting is just rotating columns, rows and columns to get a different perspective. That was OLAP operations. We also saw different types of OLAP systems. That completes this session. This was part two, let's say, of data warehousing basics. Yeah.